Hi, and welcome back to Algebra 1. Our goal for today is to start putting our pieces together for linear relationships or linear equations where we're able to find solutions on our line, take those solutions, record them in a table of values, or what's sometimes called an input-output table, and then take the results that are in our table of values or table solutions, and plot them in a coordinate plane, and draw the line that represents the entire set of solutions. The thing you always have to remember with linear relationships is there's technically an infinite amount of solutions, right? And so a couple things you have to keep in mind when you go to make your final graph. To represent the fact that there's a never-ending infinite amount of solutions is you need to make sure you always have arrows on the ends of your graphs. That shows that this line goes on forever. It stretches as far right as possible and as far left as possible. It stretches as far high as possible and as low as possible with an endless set of ordered pairs that land on that line. Now, every location on this line is technically a solution. So we can look at this line and say, all right, this line here, or this point here, which would be at 0, 2, that would be a really easy point to graph. So it would be one we would want to try to pick, right? We would pick out 0 and solve for this 2 because it would give us an easy place to graph. Whereas if I go over to, let's say, like over here, 4, something, right here, we can see that that's a solution on our line, but it's really hard to tell where our graph is going what. Is it at like 1/2, 2/3, right? It's kind of hard to tell, right? So this 4 would be an x value we would want to kind of stay away from in our table of values, right? We've talked quite a bit now about picking out x's that help us get y's that are easy to graph. So we're going to focus on that again today. When I go to pick out values in my table for x over here, I want to be smart about what I pick over here so that when I get y's, there are things like this, 0, 2. Not 4, like in between decimal fraction numbers. Because yes, they're solutions, but they're really, really tricky to put in the picture version. So for today, we're going to be working no matter what format we're given. We might be given this y equals kx proportional relationship form. We might be given slope-intercept form. We might be given point-slope format, standard format, or that sort of special notation, a function notation format. Remember, this f of x is really the same as and these two look the same. So this f of x is really just saying y equals mx plus b still, right? It's just a notation thing that's slightly different. We'll get to those special cases of x equals lines and y equals lines later on. So again, we're staying up here. We'll see x's and y's both in our original equations. In our final graphs, there will be lines because our highest degree on x for all of these is a 1, which means in picture format, we have a straight line. So our steps for today, how to go about making our table of values, which we should be pretty good at this point, to help us create the picture of all the solutions on our line or the graph. Go ahead and fill in the blanks. Remember, your ultimate first step here is always get that y equals function form. Once you have the function form, look at your coefficient, which is a fancy word for what's the number in front of my x term. If it's a fraction, then be smart about picking out your x's. Don't just use that -1, 0, 1, and 2 like we talked about. From there, we're going to replace in our x values we pick out to solve for our place on our line. So what would be the y location at that x for that particular line? Once we have 4 places on our line, I'm asking you to find 4 for each line for right now. Go ahead, graph those 4 points and connect to show that all the solutions, right? There's an infinite amount. Make sure you have arrows on the end. When you go to graph, if you don't have a straight line, since these are all linear relationships, you know you made a mistake. There's 2 places where we might make mistakes. Mistake number 1 might be, I messed up solving for my things that go in my table. So go back and recheck your math. Sometimes it's as simple as, oops, I made a sign error somewhere along the way. The other place where we make mistakes is actually graphing the point. For example, let's say I get something that looks like this, -3, 5. Where I should go left 3, up 5. Maybe I went right 3, up 5, right? Make sure you're putting your points in the place that's actually being described by that particular ordered pair. Now, sometimes when we get our table done, right? Like this would be an example of a table maybe we got 0, 0 is a place in our line, 1, 6, 2, 12, 3, 18. Now, the coordinate planes I've provided you, the biggest number here is a 10, right? The smallest one here is -10. The biggest guy up here is a 10, and the littlest one down here is -10. Now, for this, we see that our x's fit, right? There's nothing bigger than 10 or smaller than -10, so we're good there. However, when we look at our y's, we see that these two wouldn't fit, right? Well, I'm not going to let you like float a point way up here, right, in no man's land, which means we would have to count our scale by something other than 1. So no numbers on this y-axis right now just means we're counting by 1, right? Right, because there's no numbers there. We just assume we're counting by 1s, which is fine. We're still good here to go by 1s on the x because everything fits counting by 1s. But we need to get up to 18 on our y-axis. So we'd have to count by 2s here. And we'd actually have to show that in our picture, right? So we would have to actually go in and number until we got up to +20 and down to -20. But only on our y-axis did we have to change. Notice this x-axis doesn't have any numbers on it, so we're still technically counting by 1s there. So just be careful. I want all your points to actually be in the coordinate plane, nothing sort of floating outside. So we could also have something that looks like this, where our y's, they all fit. But now we have x's that are too big, which means now we have to get to 20 here, so we'd have to count by 2s on our x, but we could still count by 1s on our y. And we would show, all right, this x-axis got renumbered, counting by 2s. There's no numbers here on this y-axis, so we're counting by 1s. No numbers is 1. If I'm counting by something else, I should be showing it, so be careful. So could we have a case where we have to recount both? Absolutely, right? We have an x that's too big and a y that's too big. Now, our highest number here is a 20, which means we can count by 2s. Our highest number here is a 40, so we could go by 4s or maybe 5s, right? Something like that, that gets us to at least 40, maybe 50. Most of us like to prefer to count by 5s as opposed to 4s. So 5, 10, 15, 20, but we could do 4, 8, 12, and so on. But in this case, we'd have to show both axes change, right? We can see that now this highest number is 20, so this is counting by 2s on the x. And we can see this highest number here is 50, which means we're counting by 5s on this y-axis. All right, so just make sure if your ordered pairs don't fit between 10 and -10, that you show what you are counting by. Now, reminders from our previous lesson, we want to try to pick out x's here that are simple, easiest to use. So -1, 0, 1, and 2 would be my suggestion. They give you the best chance to get the smallest numbers possible so that you don't have to do that renumbering. But I also want at least one of these x's to be negative, just to kind of see what's going on both sides of our origin. And in this case, since what's in front of x is not a fraction, we can use those. Now over here, instead of -1, -1, 0, 1, and 2, we have to multiply by something because this number here is a fraction. And the number we multiply is by the denominator. So -1 times 4 will give us -4. 0 times 4 here, 1 times 4, 2 times 4, right? And that would give us so that we don't end up with those points that are like really tricky, hard to graph along the way. All right, so let's look at some examples. Number 1, we're going to start with an example that's in slope-intercept form to start, which is y equals 6x plus 2. Now, since this is already technically in function form, right? Y is by itself, everything else on the other side. We can go straight here to picking out values in our table of values. If not, we'd have work to do right here where we would solve for y. All right, we're going to look here. This number in front of x is not a fraction. So my suggestion here, -1, 0, 1, and 2 are going to be our x's that we're going to use to hopefully keep our values as small as possible so that hopefully we can remove that chance of having to renumber. Now, we might still have to renumber, but it gives us a better chance. If we keep those x's small, then our y's will often stay small also. All right, let's go to our work. Let's solve here. We're using x is -1, x is 0, x is 1, and x is 2. Just like we've been doing the last couple of days. All right, y equals 6 times -1 plus 2. PEMDAS from there. 6 times -1 is a -6 plus 2. Add it up. -6 plus 2 will give us a -4. All right, so one location on our line, -1, comma, -4. So we're going to take this -4 and put it into our table, right? -4. All All right, let's go to number 2. Putting in our 0 here. So y equals 6 times 0 plus 2. PEMDAS from there, 0 plus 2 to get y equals 2, which means 0, 2 is our y-intercept for this particular graph, and it's a location on our line that would be simple, easy to graph. All right, let's do our 1. 1's going in here for x, so y equals 6 times 1 plus 2. PEMDAS from there, 6 plus 2 to get a total, do your add to get 8. All right, so 1, 8 is a place on this particular line that we can use to help us graph. All right, let's put our 2 in. Y equals 6 times 2 plus 2. Multiply, then add 12 plus 2 to get y equals 14. Now, unfortunately, we ended up here with a 2, 14, which means we will have to renumber here for our y-axis. All right, since this is bigger than 10, we're going to have to recount, and we're going to have to recount to get at least 14 in there. So counting by 2s would be perfect here. So on our coordinate plane, we have to show that, right? No numbers means I'm going by 1. So I got to count 2, 4, 6, 8, 10, all the way, right? I got to show going all the way up here to 20. And if I change this positive side, I got to change down here on the negative. So this would be -2, -4, -6, -8, and so on. You're going to number until you get down here to -20. Now your ordered pairs will actually fit in that coordinate plane. All right, from there, we want to graph our points. -1, right? We saw that -1, -4, 0, 2, 1, 8, and 2, 14 are places on our line. So review, plotting our points. Remember, this -1 means go left 1. Remember, on this x-axis, we didn't renumber. We're counting by 1s there. So left 1 would be right here. Down 4 is really right there. Down 2 tick marks. All right, 0, 2 is don't go left or right, and really go up 1 line because we're counting by 2s, so be careful. 1, 8, so to the right 1, up 2, 4, 6, 8 would put us right there. And then to the right 2, up 14. So 2, 4, 6, 8, 10, 12, 14 would be right there. All right, from here, I take a ruler, straight edge, I connect, and I have to have arrows on both ends. I want this line to go the whole way through the coordinate plane. Show as many of your solutions as you possibly can. Right? If you're on your computer and you're working in a Google slide when graphing these, you'll have to go to the line, insert line that's up in your toolbar, and you have to select arrowheads. It'll default to just a segment with no arrows, so you have to add them on there, so be careful. All right, let's try another. All right, we're going to start now in standard form. Now, here's where we need to be careful. We are not in y equals format here, so we're going to have some work to do before we pick out our x's and solve for our corresponding y's. We need to get that function form first. We have the linear equation 3x plus 5y equals 30. Now, this table says input-output, but it's still always x, y. Your ordered pair or your table always goes in the format of an ordered pair, where x is first, y is second. So no matter what it puts up here, it's the x value and then your y value. All right, we need to get our function form here, so we need to solve here for the variable y by getting rid of this plus 3x part first. All right, so we're going to start by subtracting a 3x from both sides. What we do to one side, we got to do the other. So don't forget about over here with our 30. All right, cancel. We have 5y equals. Now, remember, these are not like terms. Do not put them together. There were some of us making that mistake before. All right, now we need to get rid of our times by 5. We're going to divide both sides by 5. Now, remember, dividing both sides by 5 really means I'm taking every term on both sides and dividing by 5. I'm simplifying term by term. So we have y equals 30 over 5 would just give us 6. And then -3/5. That's the fraction there. Can't be simplified. So we're going to leave it as -3/5 with an x. All right, now we want to pick out x's here. -1, 0, 1, 2 is our ultimate goal. But in this case, we have this fraction here in front of x. So we want to take those and multiply them by 5. All right, that's our denominator. So -1 times 5, we're going to use -5. This 0 times 5 would still be 0. This 1 times that 5 would now be 5. And this 2 times 5 would give us a 10. Now, those are going to give us perfect locations on our line. Now, if we had to use -1, 0, 1, and 2, it will still give us places on our line, but they will be those tricky, hard to graph locations. We want perfect spots so that when we get to our graphing portion, life is easy. All right, so let's do our work here. We're using x is -5, x is a 0, x is 5, and x is a 10. All right, substitute in PEMDAS. So y equals 6 minus 3/5 times -5. Now be careful, this is a negative here. So -3/5 times -5 will give us a plus. Now, if you didn't think of that as a negative and you did 3/5 times -5, you just have minus negative, which will give you the same result, which is perfectly fine. Now, if you can't do that -3/5 times -5 in your head, that's fine. Use your calculator, you'll get a +3. All right, from here, do your add, and we'll get a 9, which means -5, 9's on our line. So this output, or our y value here, is a 9. All right, let's keep going. Let's put in our 0. All right, y equals 6 minus 3/5 times 0. All right, -3/5 times 0 would just give us -0 still, and we end up with 6. So 0, 6 is a location on our line, or the y-intercept of this line is at 0, 6. All right, let's do our 5. Y equals 6 minus 3/5 times +5. So y equals 6. -3/5 times 5 would just give us -3. Again, if I can't do that math in my head, calculator's my friend there. 6 minus 3 will give us 3. So 5, 3 is the location on the line. All right, let's do our 10. Y equals 6 minus 3/5 times 10. PEMDAS from there. Multiply always before subtract or add, whatever you want to think about going on here. So -3/5 times 10 would just give us a -6, or subtract 6. 6 minus 6 then would just give us a 0. So 10, 0 is a place on our line. Now, these are all going to fit. Life is easy. Let's go straight to graphing. We don't have to renumber anything. So this first one, -5, 9, says go left 5. So 1, 2, 3, 4, 5, up 9, which puts us way up here. Make sure you're in the right spot. Left 5, up 9. All right, we got that guy. 0, 6 is our y-intercept. So remember, that's going to be on this y-axis. So up 1, 2, 3, 4, 5, 6. Plot a point. Make sure you're in the right location. It's not 6, 0. All right, 5, 3, right? 1, 2, 3, 4, 5, up 1, 2, 3, puts us over here in quadrant 1. And 10, 0 would be go to the right 10, don't go up at all, right on your x-axis. All right, from there, take your ruler, connect your dots. I want a line that goes the whole way through the coordinate plane, needs an arrow here and an arrow here because our solutions go on forever. All right, let's try one more. We're going to start in what's called point slope format. Oh, what's going on here? This is just x1, y1. All right, that's a point on our line. All right, so we want to, if we have this point slope, can we get the picture of our graph of all of our solutions? It's not in function form, so we got to start there first before we pick out x's for our table. So y minus 1 equals 2 times x plus 2 is our linear equation, and point slope we're given. I want to get our function form by taking the 1 that's here, distributing, and taking the 2 that's here and distributing, and then solving for y. So 1 times y is still y. 1 times -1 is still -1 or -1. All right, 2 times x is still a 2x, and 2 times +2 would give us a +4. All right, here's the side we're focused on, where y is. We need to get rid of the subtract 1. The way to do that would be the inverse of to add 1 to both sides. Now be careful here. Make sure you're only putting things together that are like terms, which is this 4 and the 1. So we have y equals 2x plus 5. All right, this number, this coefficient in front of x is not a fraction. So let's just use our regular old -1, 0, 1, and 2. We don't have to be picky here. Every x we pick will give us perfect locations. All right, let's go. We're going -1. We're going 0, 1 and 2 to get some solutions on our line. So y equals 2 times -1 plus 5, multiply, then add when following PEMDAS. So y equals a positive 3 here. So option 1, y is -1 comma 3 is a place on our line. All right, let's go when x is 0. That will give us what's called our y-intercept of our line. 2 times 0 is just 0, so plus 5 will give us a y value of 5. So 0 comma 5 is the location on our line. All right, let's do when x is 1. Where would our y be? So 1's in, multiply first. We get 2 plus 5, which gives us a y value of 7. So 1 comma 7 is the location on our line. All right, last one. Let's try when our x is 2. That'll give us enough points to help us graph all the solutions, the infinite amount. So 2 times 2 is 4 plus 5 to get a y value of 9. So we have 4 places here. Everything's smaller than 10 and bigger than -10. We don't have to renumber. Life is simple here. So let's go. -1 comma 3 would put us over here in quadrant number 2. 0, 5 is your y-intercept. Up 5 would be right here. 1 comma 7 right here. And 2 comma 9. All right, take your ruler, right? Take a straight edge. Connect, draw in your line to get something that looks like this. Make sure, again, we need arrows on the end because our solutions go on forever. All right, I hope that helps you attack your work for today. See you guys later.